Hi everyone, welcome to my channel. My name is Eugene and for today, I will be discussing the tutorial for complete basic design of fire detection and alarm system. Before we start guys, I just want to give a brief background first about myself. I am a licensed electronics engineer and I have been working for fire protection industry for more than 15 years. Currently, I'm a senior fire alarm designer, but I started as a draftsman a couple of years ago. So while in lockdown, I thought why not be productive and share with you guys the basics and later on we will be discussing too the designing of fire alarm system. So let's start. The main objectives of this tutorial are to familiarize with the main components of fire detection and alarm system, to gain knowledge of NFPA standards, to know the basics on how to use the standards, to study the fundamentals of fire detection and alarm system, and to learn the design requirements. And last, we will be having an actual online tutorial using CAD on how we design the fire alarm detection and alarm system. Okay, so let's proceed with the main components of fire detection and alarm system. But before that, I want to define first what is fire detection and alarm system. There are three main importance of having a fire detection and alarm system in the building. First is to protect the occupants of the building to safely evacuate during fire. Second one is to protect the building from damage from fire. And last, to establish a safe environment for rescuer like firefighters and trained personnel during fire. There are two types of fire detection and alarm system. First one is addressable fire detection and alarm system. Second one is the conventional fire detection and alarm system. In this tutorial guys, we will be focusing only on addressable fire detection and alarm system. Why? Because it has a lot of advantages compared to conventional fire detection and alarm system. And most of the time, the designers are using only addressable fire detection and alarm system. And conventional designers are using this type of panel only in special system like fire suppression system. These are the major components of fire detection and alarm system. First, we have the fire alarm control panel. The second one is we have initiating devices. There are a lot of types of initiating devices. One is a smoke detector, heat detector, duct-mounted smoke detector, photo beam smoke detector, air sampling detector, video smoke detection system, flame detector, manual push station. And the third component of fire detection and alarm system is audible and visual notification appliance. They are alarm bell, horn, strobe, or combination of horn and strobe, speaker, or combination of speaker and strobe. And the last major component of fire detection is module. There are three types actually. One is control module, the other one is relay module, and the third one is monitor module. So these are the images of the major components of fire detection and alarm system. Like what I said earlier, we have the first one which is the firearm control panel, this one, and the initiating devices. These are the initiating devices. We have the heat detector, smoke detector, duct detector, flame detector, projected beam smoke detector, air sampling detector, manual full station, manual call point, and the modules, monitor module or relay module. These are the control module, which controls our notification appliance like alarm bell, horn strobe, or speaker and speaker strobe, and a relay module which controls the other emergency control interface like the shutdown of AHU. Don't worry guys, we will discuss all this later on in the other slides. And we have also the control for elevator and the control for access control. So what is fire alarm control panel? It is the heart and brain of fire detection and alarm system. It processes the input and control of all necessary fire safety function including emergency and alarm notification. This is like CPU guys in a computer. So without this, system will not work. What is initiating devices? It is a sensor used to detect a fire by either smoke, heat, or electromagnetic waves such as ultraviolet or IR. Basically, in a fire, the combustion particles that can be found mostly are smoke, heat, and electromagnetic waves, though we have also some other dangerous gas like carbon monoxide. But in this tutorial, guys, we will just discuss more about these three particles, which is very important in detecting a fire. So this is why these devices are invented, no? Basically to detect these three um, types of combustion particles that can be found by fire in a fire. So we'll discuss this SPAT type smoke detector. Why it is called SPAT type? Because there's a limitation in the coverage. Let's say we have a big building. One smoke detector cannot monitor the whole building. There's only a certain spot where it can detect only or a coverage. So this is the reason why it's called SPAT type smoke detector. So this type of sensor, smoke detector, is used to detect a fire by smoke. That's why it's smoke detector. It uses a technology wherein a light source and a photosensor triggers fire alarm when the alarm threshold is met by either light obscuration or scattering technology. We will discuss this more in the next slides, guys. These two technologies which the smoke detector is using. But before we go to that technology or discuss this technology, I want you to first know the components of a smoke detector. So one is the smoke detector head. We're calling it the detector head. The second one is the base. This detector head will be mounted to this base. Base is actually where we are terminating our cables or wires. And the next one is remote LED. This remote LED will be used only if, let's say, we have a smoke detector installed above the ceiling or in the floor void where it is concealed, no? Because without this remote LED, um, once this smoke detector activated, this LED cannot be seen now um, by the people if it's activated. Because if it's installed above and concealed, the only way to see this is to install a remote LED. So this is the technology which the smoke detector used. The first one is light scattering. Why it is called light scattering is the theory only is we have this um, light source, the infrared LED, and we have a photosensor or the photodiode light receptor. Normally, guys, if there is no smoke inside the detector, what happens is this light emitted by the photo source or the light source are not received by the photosensor, like what you will see here in this picture. But once there is a smoke enter to this detector head or the chamber, some of the light will be reflected to the photosensor. Once the photosensor receive those light, it will automatically raise alarm when it reaches the programmed alarm threshold. The other one is light obscuration technology. When we say light obscuration technology, normally the light source, all the lights coming from the light source are received by the photosensor, like what you will see here in the picture. It's receiving the light, all the lights coming from the light source. But when there's a smoke enters the detector head or chamber, it will block some of the light. And when that particular alarm threshold are met, then the detector will activate. The next type of initiating devices is the spot type heat detector. Same with smoke detector. It is also a spot type, but it is a sensor which detects a fire by the presence of heat. So unlike in smoke, this type of detector is detecting the presence of heat. So there's a certain temperature, available temperature that can be selected from the manufacturer, but it depends uh, what the project needs. If it's installed indoor, the temperature is different. Alarm temperature is different from indoor to outdoor. So how this heat detector function? If let's say the heat detector that we considered in our design is like 68 degrees Celsius, once the fire reaches this temperature, this heat detector will activate automatically. But there are actually types of heat detector also. One is what we call fixed type, and the other one is rate of rise. What is the difference between two? When we say a fixed type, it's fixed. When it's triggered, it cannot be restored. So once the temperature is met, like 68 degrees, if this is the alarm set point, once this temperature from the fire is reached, this detector will be activated and it cannot be restored anymore. But in rate of rise, it's actually sensing how many degrees the temperature is rising per minute. So this is the difference between two. So what are the components in a heat detector? We have same with smoke detector. We have the detector base and remote LED. Like what I said earlier, fixed type spot type heat detector is not restorable. Once it's the designed alarm set point is reached, it cannot be restored anymore. The other one is rate of rise. Normally, the rating of rate of rise heat detector is set as 8 degrees Celsius per minute. So if the fire reaches this setting, like 8 degrees per Celsius per minute, the rise of heat, then this detector will trigger. But compared to fixed type heat detector, this type of heat detector is restorable. The next one is the duct mounted smoke detector. It is designed to detect product combustion, which is smoke. Same with smoke detector, but this time this smoke detector is mounted in the HVAC duct. But compared to smoke detector, this should be listed, no? Because we all know that in detector is mounted in the HVAC duct, there will be an expected more air velocity. So if it's just a normal smoke detector, it may not function um, like what detector can do. So once we have a duct detector, uh, take care guys that make sure that you are using a listed smoke detector for duct application. Okay? So the next type of smoke detector is the photon beam smoke detector. This is same like what we have in spot type. Same theory, like I mean same technology, where we have a light source, transmitter, and another one is the receiver put a sensor, something like that. But this time, the area that can be monitored is bigger compared to spot type. That is the difference between two. So rather than installing one detector, I mean a lot of spot type detector in a big area, if we can install only one, like a photo beam smoke detector, that is the advantage of having this type of detector. But the ceiling height where this the type of detector is used mostly is where we have uh, high ceiling, which is like most of the time more than 9 meters. We're installing smoke detectors or heat detector is very hard because of high ceiling. In case of maintenance and at the same time also in the delay of detection, this type of detector is the best detector to use. So this is how it works, guys. What you will see here, if there's a fire, it uses the technology of light obscuration. So once the smoke block this light emitted by the source, it will trigger the fire alarm. The next one is the air sampling detector. This is the more advanced type of smoke detector, guys. This is very high in sensitivity. It is used widely in data centers where and a lot of areas where we have very expensive equipment that we need early detection, very early detection. Why it's called very early detection is it uses the technology of continuously drawing air from pipe where we have a holes or we what we call air sampling point going by the pump going to the sensor inside this where we have the sensor. So by the use of this aspirator or the pump, guys, it can increase the sensitivity or the time to triggers the alarm. Because imagine we have continuous 24 hours. This this pump is continuously sucking the air to monitor the air within the room. Imagine if there's a smoke, it will easily travel to the sensor without delay because of the pump. That's why it's called very early detection. Though it's more expensive, but in in terms of reliability, guys, I recommend using this type of sensor. The next one is the flame detector. These are mostly used in where we have a lot of combustible or flammable liquids like oil tanks, where we have a diesel generator, where there's involvement of combustible and flammable liquids, where from the liquid, I mean the fire coming from the flammable liquids, it's emitting UV and IR. So this is the best detection to use. The other initiating devices is the manual pull station or manual call point. So they're both the same. I mean the function. This is manually operated by human. That's why it requires human intervention. But there are two types of manual pull station. One is what we call single action, and the other one is double action. Where we need to use single or double action. Well, it depends, guys, where your application is. Let's say your fire detection and alarm system is in business occupancy, like offices. In offices, we're expecting that it's not open for public, no, for people to just come inside the building and outside, and it's not controllable. I mean, the crowd, uh, only employees will be there. most of the time, 24, I mean, within an office hours. So in that case, in that particular occupancy, the best to use is single action. When we say single action, you just need one action to trigger the fire alarm. You just in this one, you just need to pull down. Once you pull down this handle, it will activate fire alarm. In double action, you have to lift first this cover, then only you can pull now this handle. This is how it works. That's why it's called double action. So we're using this double action mostly in sensitive place like in say hospital or in assembly like in the malls or stadiums where there possibility that children or other people which they're not aware of this device, maybe they will accidentally trigger this device. So using double action will avoid this false alarm because of the people who will just pull this accidentally. So with this, there will be protection. The other one is the call point. It's the same. You just break the glass, guys, and it will activate the fire alarm. So we will go on now on the third component of fire detection and alarm system, which is the audible and visual notification appliance. These are the electronic devices using fire alarm to notify the occupants within a building, no, to evacuate either audible, visual, or both. So I know most of you guys know are familiar with this type alarm bell. This is like what we have in school, no? It sounds something like that also, where it's continuously ringing, and it's very annoying to the to our ears if it's no continuous, no. So the first one is alarm bell, horn strobe, speaker strobe. Okay, we'll discuss it. Alarm bell. It is an electronic bell used in audible fire notification that produces continuous ringing sound to alert the occupants in the building. So the typical range of sound pressure level output is 80 to 100 dBA maximum. So if we are more than 150 dBA, then it's dangerous to our ear. The only permitted level of dB that our ear can hear is around 110, I think. Yes, 110 to 115 or 110 as per NFPA. So the next one is horn. It is used an audible fire notification using a different sound pattern to alert the occupants in the building. Typical range of sound pressure level is the same, almost the same with the bell, but it sounds differently compared to bell. It's programmable actually. It can be continuous. It can be temporal pattern. There's a lot of pattern that can be used here. Sound pattern. The next one is combined horn strobe. So when we say combined horn strobe, guys, it's a combination of horn and at the same time we also have this strobe here. So typical range is same with what we have in horn, but with additional of candela rating. You mean the illumination with each around 15 to 110 candela for strobe. And the other type is speaker, guys. This is different from horn. Why? Because this speaker will give us the complete information during fire emergency. This will give you the instruction or information like evacuate now. We are in like in fire emergency, something like that. You will hear some information from the speaker itself. Unlike in horn where we just have like a sound, no. But of course there is an application where we are going to use this speaker, not in every occupancy. It depends on which application we're going to use fire alarm. Speaker strobe, same what speaker, you just added strobe. And the last component is the monitoring module or the control and relay modules. So the monitor module is used for monitoring other initiating devices such as supervisory switch where or the tamper switch that we have in OS&Y gate bulb. No, this is to monitor the gate bulbs. If someone closed the gate bulb from sprinkler, then it will give us supervisory signal from to the fire alarm. And it is also used for monitoring of water flow switch. If in case the sprinkler in the building operates or one of the sprinkler break because of the fire, it will give us also alarm that the building is in fire. Okay, so and the other one is it is used to interface other system like fire suppression, like let's say it's either Novec or FM200 or kitchen hood fire suppression system or for monitoring of signals from power pump, power water tank. These are the modules that we are going to use. The next one is relay module. This module is actually what we use, guys, for controlling other emergency interface like shutting down of AHU during fire, power shutdown, or this is also the module that we use for controlling motorized fire smoke damper. Motorized fire smoke damper are used in every duct penetration in a fire-rated wall, no? So in case of fire, this fire resistance of the wall will still be maintained because otherwise, if it's not closed, then how can we say that that wall is still fire rated if it's open? No, the fire will just spread easily from one point to the other point. So these modules are used also to control that fire smoke damper. And the other one is elevator recall. Elevator recall, guys, is just like to bring the elevator down to the ground floor or the level for evacuation. No, so if in case there's a fire started in the building and the fire alarm triggers, if people, let's say, is inside the elevator in 26th floor, once the fire is activated, this elevator will automatically go to the ground floor. So, and from that, it will stop and open. It will not close anymore. It will open. So people cannot use the elevator. And people can just go out from the elevator and evacuate from ground level. So this is the one. And the other one is shutdown. No, relay module is also to use to shut down the elevator. We will discuss it later on, right, guys, why we need to shut down the elevator and when do we shut down the elevator. The other one is to control security access control and activation of smoke exhaust control. So there's a lot, guys. Uh, why we use relay module. Control module, guys, is just for controlling conventional audible or visual notification appliances, or sometimes we're also using this for controlling fireman's cell phone. But in this lecture or tutorial, guys, we're not discussing about fireman's cell phone. So that's it. This control module is just for controlling audible and visual notification appliances. In this slide, guys, I will give you an idea how this fire alarm system works now. Since now that you know the fundamentals or major components of fire detection and alarm system. So we have two operations. One is automatic and one is manual. When we say automatic, fire detection is coming from the smoke detector duct, heat, everything flame, except for manual and manual call point. There are manuals. So let's take a look at in this slide how this automatic will work. So once this smoke detector triggers, as you will hear the sounds coming from the horn strobe. And at the same time, all the controls in each elevator access control will be controlled, and you will see the information from panel Y. You will see here in this panel has LCD, no, to for the firefighters or trained personnel to see where the fire is coming or originated. Okay. Now we go to the manual operation, guys. Let's say if we trigger the manual push station, what will happen? It is actually the same with the automatic. It's just the operation differs. So we trigger it manually. But what happened is, same, our horn strobe activates for alarm bell, and the interface for AHU, elevator, access controls are also activated. At the same time, we're receiving information from